If you use AI tools for your daily work, you've probably run into this incredibly specific, incredibly annoying frustration.
Oh, I think I know exactly where you're going with this.
Right. You ask a large language model a question on, say, a Tuesday, and it gives you this brilliant, nuanced answer.
Yeah.
But then you ask it the exact same question on a Wednesday, and it gives you an absolute unhinged hallucination.
Completely loses the plot.
Exactly. It makes some facts. It forgets everything you just talked about. And you're just left staring at your screen wondering, like, what just happened?
And your immediate instinct as a user is to look for a control mechanism. I mean, we are so conditioned by decades of using software to believe that if a machine is acting erratically, there have to be a setting we can tweak to, force it back into line.
Which brings us to the massive myth we are dismantling today.
Yes.
Because if you want an AI to stop hallucinating and just give you straight facts, conventional wisdom says you just open the developer settings, you find the slider labeled temperature, and you slam it all the way down to 0.
Boom. Problem solved.
Right. The AI stops being creative.
Yeah.
And it becomes this reliable, factual machine. But according to the research notes we are diving into today from author Swali Banerjee, doing that does not actually make the AI smarter or more accurate.
Not at all.
It just makes it confidently, consistently wrong.
Yeah, that's the real danger here.
So welcome to the deep dive. Our mission today is to fundamentally rewire how you think about controlling these models. We're looking at Banerjee's notes to really unpack this.
And, what's fascinating here is how a simple misunderstanding of a physics term has led so many people down the wrong path with AI. To see why the zero temperature trick fails, we first have to look at why we collectively assumed it would work in the first place.
Right, because it feels so intuitive.
Exactly. It stems from a fundamental error in vocabulary. We borrowed the word temperature from the physical sciences, applied it to complex computer science, and just assumed the physical rules came along for the ride.
Okay, let's unpack that. Because in thermodynamics, temperature is essentially a measurement of kinetic energy, right?
Right.
Like if I boil a pot of water, I'm adding heat, I'm raising the temperature, and those water molecules are just bouncing around frantically.
Yeah, they're chaotic.
That system has high entropy, which is basically a high degree of physical disorder or chaos.
But if you remove that heat, like if you freeze the water, those molecules slow down. They lock into a rigid, predictable, crystalline structure.
Ice.
Exactly, ice. The chaos physically stops. The entropy is reduced because the system itself has fundamentally changed.
So naturally, when tech companies put a temperature dial on an LLM, our human brains think, if I turn this down to absolute 0, I am freezing the AI's digital brain.
That's the logical leap everyone makes.
Right, like I'm slowing down the frantic bouncing of its thoughts so it can give me a cold, hard fact. Why doesn't that work?
Well, it's a beautiful analogy, but it is entirely wrong when applied to neural networks. Banerjee's core distinction in the notes is that lowering the temperature in an LLM does not change the underlying system at all.
Wait, it doesn't?
No, not even a little bit. To understand why, we need to briefly demystify what an LLM is actually doing beneath the hood.
Okay.
When you type a prompt, the model isn't thinking in the human sense. It is running a massive mathematical calculation to predict the next token.
And just to clarify for everyone, a token isn't always a full word, right? It can be a chunk of a word or even just a piece of punctuation.
Exactly. The AI's entire universe is just a sequence of tokens. And for every single token it generates, the model calculates a probability distribution.
Okay, probability distribution. Let's visualize that.
Imagine a massive roulette wheel with tens of thousands of slots, where every single slot is a possible next token.
That is a big roulette wheel.
Massive. But the slots aren't equal sizes. If the model is confident the next word should be apple, that slot takes up, say, 60% of the wheel. If it thinks the word could be banana, that takes up maybe 10%. And a complete hallucination, a word that makes zero sense in context, might take up a tiny fraction of a percent.
Okay, so the underlying system, the AI's actual knowledge and uncertainty, is represented by the size of the slots on that roulette wheel.
Yes.
So if I turn the temperature down to 0, I'm assuming that I'm wiping those tiny hallucinated slots off the wheel completely. Like I'm removing the bad options.
And that is the trap. The wheel does not change at all.
Please, seriously.
Seriously. The mix of good tokens and bad tokens, the correct words, and the hallucinations remains completely untouched. The underlying math, the AI's internal uncertainty, is exactly the same.
But what does the dial actually do?
What the temperature dial actually changes is the mechanism of the ball dropping into the wheel. It changes how you sample from the system, not the system
Oh,
itself.
wow. Okay, so if the wheel is still exactly the same, what does a zero temperature setting actually do to the ball?
It magnetizes it.
Magnetizes it.
Yeah, think about it like this. At a high temperature, the ball bounces around normally. It will usually land in the biggest slot, but occasionally it'll bounce into a smaller 10% slot, which is what gives you a more varied creative response.
Right, that makes sense.
But when you drop the temperature to zero, you artificially magnetize the ball so that it is physically forced to drop into the single largest slot every single time without fail.
Oh, so it completely collapses the variation in the model's output.
Exactly. It just repeatedly picks the highest probability tokens.
I mean, I can definitely see why people fall for this illusion. Because if I am the end user and I set the temperature to zero, the AI does stop giving me wild, varied answers.
It feels like it calms down.
It totally is. If I ask it the exact same question 10 times, I get the exact same answer 10 times. And, as humans, we are wired to view consistency as reliability.
Right, we conflate confidence with correctness. And according to Banerjee, in the world of generative AI, that is the most dangerous assumption you can make.
Why dangerous? Doesn't consistency equal correctness?
Well, think back to the roulette wheel. Yes, at zero temperature, the mechanical ball is forced into the biggest slot on the wheel every time. But what if your prompt was ambiguous?
Ah.
What if you didn't give the AI enough background information?
Oh, I see. If the prompt is bad, the AI's math is going to be skewed from the start. So the biggest slot on the wheel might accidentally be a completely wrong answer.
Precisely. If the model is confused by what you asked, its highest probability guess, that biggest slot might be a total hallucination.
Yikes.
By setting the temperature to zero, you haven't fixed the AI's confusion or reduced the entropy. You've just guaranteed that it will feed you that exact same hallucination word for word every single time you ask.
So we aren't making it smarter. We're just forcing it to be stubborn.
That's a great way to put it.
It's like forcing someone to guess the answer to a trivia question they don't know, but telling them they aren't allowed to show any hesitation.
Right.
They aren't allowed to say, or I think maybe. They just have to confidently shout out whatever their first instinct is, even if it's wildly incorrect.
You've basically put a blindfold on and pretended the chaos isn't there. You haven't reduced the model's internal entropy. You've just hidden its uncertainty from yourself behind a wall of sheer deterministic confidence.
Wow. Okay, so setting temperature to zero is basically a placebo.
Pretty much.
So if we can't just tweak a software setting to fix the reliability problem, how do we actually fix the entropy problem? I mean, the only real way to change the AI's output is to physically change the size of the slots on the roulette wheel.
Yes.
And the only way to do that is to change the input we give it. We have to change the prompt.
And this is where Banerjee's notes shift from tearing down the myth to building up the actual practical solution. Real entropy reduction, actually making the AI less confused and more accurate, comes from structured communication.
Okay, structured communication.
Yeah, you have to actively narrow the probability space so that the correct answers naturally become the only mathematically viable options.
So what does this all mean for us? Because when I hear the phrase structured communication in the context of AI, my mind immediately jumps to coding.
Oh, like writing in code.
Yeah. Am I supposed to be talking to the AI exclusively in rigid JSON code now to force it to be accurate? Because you see people online posting these massive, complex prompts written in JSON.
Right, with all the brackets and curly cues.
Exactly. For anyone who hasn't encountered it, JSON stands for JavaScript Object Notation. It's this very rigid data formatting language that software engineers use to pass data between applications.
Yes.
And people use it in their prompts because they think treating the AI like a traditional database will force it to be accurate.
It is a very common reaction to the hallucination problem. But Banerjee explicitly debunks this in the text. Structure does not just mean JSON.
It doesn't.
No. JSON is fantastic if you are building an automated pipeline where one machine is directly feeding data to another machine. But if you are a human user asking an AI to perform a complex reasoning task like analyzing a document or summarizing a strategy, forcing it to read and write in JSON is actually counterproductive.
Wait, why is it counterproductive? I mean, if it's a computer, shouldn't it prefer computer logic?
You'd think so, but it comes down to how an LLM distributes its computational resources. LLMs use a mechanism called attention to weigh the importance of different tokens in your prompt.
Sure.
If you write your prompt in JSON, the model has to spend a significant portion of its attention budget just parsing the syntax. It has to dedicate math to figuring out if every curly bracket is closed and every comma is in the right place.
Oh, so it's wasting its brain power on formatting instead of actually thinking about my problem.
Exactly. Natural structured language allows the model to spend all of its computational energy on the logic and the reasoning of your prompt. You don't need code to structure a conversation. You just need a methodical approach to narrowing the AI's choices.
Okay, let's dive into that methodical approach. Let's build a real-world scenario to see how natural language structure physically alters that probability wheel we talked about.
I love that. Let's do it.
Okay, instead of just listing out theories, let's say you and I run a small business, and we are staring at this dense 20-page vendor contract. We want the AI to review it.
Classic use case.
Right. If I just upload the PDF and say, tell me if this contract is good, the roulette wheel is massive.
Huge.
The AI has to guess what good means, what industry we're in, and what we actually care about. The odds of a hallucination are incredibly high.
Because the entropy is high. The model is flooded with uncertainty. To fix this, Banerjee outlines 4 core pillars of natural structure: task, context, constraints, and output format.
Task, context, constraints, and format.
Okay, let's start applying them to your contract. The first pillar is the task. You need a clear, uninterpretable directive.
So instead of tell me if this contract is good, the task becomes something like analyze the termination clauses and payment terms in the provided document.
Perfect. Immediately, you have shrunk the wheel. The model no longer calculates probabilities for tokens related to marketing or HR law or general business advice. It isolates its mathematical weights entirely around legal termination and finance.
But it's still just floating in a vacuum, right? Like, it doesn't know who we are.
Exactly. Which brings us to the second pillar, context. And this ties into something crucial about how these models operate, which is the context window.
Right, because an AI doesn't have permanent memories. It only has this context window, which is essentially its short-term active working memory for your specific conversation.
Yes. And if you don't fill that window with relevant background, the AI will try to pull from the vast, chaotic ocean of its pre-training data to fill in the blanks.
Which is where it hallucinates.
Precisely.
So for our contract, the context would be, we are a small retail business with tight cash flow. We are looking for hidden fees, auto-renewal traps, or penalties for early cancellation.
Yeah.
By putting that into the context window, we've basically preloaded the AI's neural pathways. We've told it, don't look at this like a multinational corporation. Look at this from the perspective of a small business worried about cash. The probability wheel just got dramatically smaller and more focused.
You are actively shaping the underlying mathematical distribution, which leads us to the most powerful tool for entropy reduction: constraints. These are the boundaries you place on the AI's logic.
Constraints are fascinating because they are often negative,
Yeah.
right? We tell the AI what not to do.
Exactly.
So for our contracts, the constraints might be focus exclusively on financial risks. Do not summarize standard boilerplate legal language. Avoid complex legal jargon in your explanation. But how does telling the AI to avoid jargon actually work on a technical level?
Well, it functions almost like a mathematical filter. In the industry, this is related to a concept called logic bias, though you are triggering it purely through natural language.
Logic bias.
Yeah. Essentially, when you explicitly state avoid legal jargon, you are heavily penalizing the probability scores of a massive chunk of the AI's vocabulary dictionary.
Oh, wow. You're literally taking the jargon slots on the roulette wheel and shrinking them down to 0%.
You are mathematically boxing out the noise. The model physically cannot traverse those high-entropy complex legal pathways because your constraints have walled them off. It is forced to route its logic through simpler, more direct vocabulary, which inherently reduces the chance of it drifting into a hallucinated tangent.
That makes total sense. And that leaves us with the final pillar, output format. Which seems simple, but it's really the final guardrail.
It is.
If we tell the AI, provide your analysis as a bulleted list, with the severity of the risk bolded at the start of each bullet, we remove any final hesitation.
Because ambiguity in formatting can cause an LLM to stumble right at the finish line.
Right.
If it has to guess whether you want a narrative essay, a data table, or a quick summary, that uncertainty bleeds into the word choices. By dictating the exact physical look of the output, you let the AI lock in its presentation strategy immediately.
Freeing up maximum processing power for the actual analysis of the contract.
Exactly.
Task, context, constraints, output format.
Uh-huh.
You know, when you look at those 4 steps, you realize that none of them require you to act like a software engineer.
Not at all.
You are just using plain English to build a structural corral around the AI's thoughts.
Yeah.
You are doing the heavy lifting of reducing the machine's internal chaos before it even starts generating a response.
And that is a much heavier lift than just sliding a temperature dial. It requires the human user to think critically about their own objective before they ever hit the enter key.
There's a quote from Banerjee's notes that fundamentally reframes this entire dynamic. And I think it's the ultimate takeaway for anyone listening who wants to stop fighting with their AI tools.
Oh, I know the one.
The quote is, "You don't cool an LLM into correctness. You guide it into clarity."
Guide it into clarity. It's so good. It places the responsibility back on the user, but in a way that provides actual agency.
Yeah, it empowers you.
You aren't relying on a placebo setting to magically fix a lazy prompt. You are taking active control over the AI's probability engine through the rigor of your own communication.
It changes the entire relationship from a frustrating tech support problem into a collaborative process. Let's pull back and look at the whole picture we've painted today.
Sure.
We started with this pervasive, comforting myth that AI models follow the rules of physical thermodynamics, that turning the temperature down to 0 would freeze out the hallucinations and leave us with cold, hard facts.
But we discovered that in the realm of token prediction, temperature doesn't alter the AI's internal uncertainty. The massive roulette wheel of probabilities remains exactly the same.
Right. We realized that a 0 temperature setting just magnetizes the ball. It forces the model to relentlessly pick its top guess, giving us an illusion of consistency.
And it blindfolds us to the fact that if our prompt is weak, the model will just confidently and consistently hallucinate.
Which brought us to the true mechanism of control. Accuracy doesn't come from a dial. It comes from physically narrowing the probability space through natural structured language. Task, context, constraints, and format.
Guide it into clarity.
It's a massive paradigm shift. But, as always, I know you have a final thread to pull on. Now that we know how this actually works, where does that leave us with the temperature dial? Should we just ignore it entirely?
Well, this raises an incredibly counterintuitive question to mull over the next time you log into one of these platforms. If setting the temperature to 0 just forces the AI to confidently repeat its top guess, masking its internal confusion,
Yeah.
could it be that using a slightly higher temperature is actually safer?
Wait, safer. Because it allows the chaos back in?
Because it exposes the chaos. Think about it as a diagnostic tool. Yeah. If you write a prompt, leave the temperature a bit higher, and the AI starts generating wildly different hallucinated answers every time you regenerate the response, that isn't a bug.
It's a feature.
It is the model's way of exposing its own uncertainty. It is physically showing you that its probability wheel is too wide. It's a warning light flashing, telling you that your context wasn't clear enough, or your constraints weren't tight enough.
Oh, that is brilliant.
Mhm.
The variation isn't a failure of the machine. It's feedback on your prompt.
Exactly.
If you get wild answers, it means you haven't guided it well enough yet. You use the high temperature to test your structure, and once your structure is rock solid, the answers will naturally stabilize because you've left the AI with no other mathematical choice but to be correct.
It really is a completely different way to interact with this technology.
Thank you so much for breaking down the mechanics of this with us today.
Oh, anytime. It was a lot of fun.
And for everyone listening, remember that the magic 0 temperature button is just a mirage. The real power is in your own words. Stay curious, take off the blindfold, and keep guiding those models into clarity. We will catch you on the next deep dive.